this video, I'm going to take a brief departure from our talk about inheritance, just briefly, to talk about constructors. You're going to see how it all ties back in just a minute. So, in yesterday's videos, we were looking at the program.cs class, and there we wrote a line of code, auto my car equals new auto. And I pointed out that the parentheses at the very end seemed a bit out of place, right? After all, the parentheses operator is for method invocation, exactly. So what I didn't say at the time, but may have kind of implied, was that every custom type that you create, every class that you create, inherits from a base class called system.object. And the system.object defines a default constructor, which is a special kind of method that automatically is called each time that you call the new operator. It's used for initializing the object. In other words, get the object into the right state before that object is used by the client code. So when we wrote our class, we decided not to include a constructor when we wrote our auto class. Now, truth be told, I didn't even talk about constructors at that point. But we made a choice not to define a constructor, not to override the base class's implementation of a constructor. In other words, what's automatically generated whenever the C# compiler goes to work and compiles our class into intermediate language. So the default constructor was called whenever we called the new operator in our program.cs, like we did right here. However, we can override that base class constructor by writing our own code. And let's write it like this. I'm just going to go here right underneath our declaration of fields, and we're going to go public auto. Whoops. And here we would do important initialization stuff here. And just for kicks, we're going to go console write line initializing, just to prove the point that this actually does get called. Okay, so yes, by default, the constructor has the same name as our class. Also, even though we didn't define a return value, it's implied that it's always void. Okay, so we don't put the word void, we don't put any return value there. So what types of things should happen in the constructor? What kinds of important initialization stuff should we be putting there? Well, that really depends on how you want to do it. As we get past the basics of the syntax, we're going to focus more on the strategies of building object-oriented programs, and that'll dictate to a certain degree on how we go about doing important initialization stuff. One popular thing to do is to retrieve data from a database and to depopulate all the fields of the newly instantiated object. Okay, so I'm going to show you how to do that next week. Let's run the application while we're thinking about it here. And you can see that I created two instances of the auto class. One here at the very top where I uncommented out this code, and then one at the bottom when we created a new instance of truck, because the truck is deriving from that implementation as well, since it's pulling all of its properties and methods from the base class auto, just like we talked about in the previous video. Okay, so regardless of the specifics of what you do inside of the constructor here, which kind of pick up this conversation again, the idea is that you should always initialize a new object into a valid state, whatever that means for that particular object. So after you initialize a new instance of a class, it should be ready at that point to be used. It should be ready to go. So up to this point, the fact that we don't have anything defined in the constructor in our previous examples hasn't really been a limiting factor. But that's only because we don't have a very complex application that we're working with just yet. When you write real applications, you will almost always want to give careful consideration, at the very least, to what it will take to get your new instance of this class into a valid state before it's ready to be used. Okay, so constructors are an important event in the life cycle of an object that allows you to plug in your code and take control of the initialization of a new object with the intent of getting it into a valid state. And in order to accomplish this and to make construction of a new class flexible to that code which consumes it, like the program.cs class here, we might want to give our class more construction options. In other words, we can create overloaded versions of the constructor. So, for example, we might want to create a version of the constructor that we can pass the initial property values into for things like model and maker and color, okay, to get it into that initial state so that we don't have to rely on code like this to do that in subsequent lines of code and take the chance that the consumer of our class didn't do it, all right? So that's actually one very popular use of a constructor, and it fits the criteria for a constructor very well. And I want to stop right here and pick up that very topic about overloading the constructor in the next video. So we'll see you there. Thank you.